Hello, thank you very much for having me here. I'm usually short on time, so I'm going to start right away. I want to start with this quotation. In 1899, Dorothea Klumpke, who was an astronomer, said, "Astronomy knows no boundaries, no rank, no sex, no age." And that is, of course, completely wrong. This is absolutely not the case. And it would be going too far to claim that there is sort of a true gist to this quote, because it is wrong. I cannot state this enough. But if you compare astronomy, for example, to other sciences of the time, like physics or chemistry or mathematics, you quickly realize that, in fact, a number of players are involved in astronomical research that would have had no chance in other disciplines. We are talking people from working-class backgrounds. We're talking women like her. We're talking people who have never gone to university. And in this talk, I want to take a look at these different actors, these different researchers. And I will argue that because we have so many different research approaches in astronomy at the time, that, and I'm oversimplifying vastly here, basically there was so much available to do that everybody could just join in if they liked. That's a stretch, but okay, let's get started. In all of this, her biography will sort of serve as a red thread throughout the talk. And I'm going to keep this short, which is really hard to do because it's a very interesting biography, but I'm going to do my best. She was born in 1861 in San Francisco. So she's an American, but her parents are Germans who had moved there during the gold rush and made lots of money, not because they found gold, because no one found gold, but they built real estate. And real estate, you could make money with that, of course. And they used that money to provide all of their daughters with an excellent education. They have 5 daughters. And at a time when girls, if they even go to school, they go to elementary school and that's it. All 5 of the Klumpke daughters will have academic degrees. So that's extremely unusual. And I just want to mention in passing the most famous one. It's Augusta. Augusta studies medicine, and she will become a neurologist and do groundbreaking research there, together with her husband, Jules Desjardins. And she has studied medicine in Paris. That's the same place where Dorothea will study, and she studies mathematics. And in 1886, she's awarded her degree as one of the first women in France to get a degree in mathematics. And the very same year, she moves to Paris Observatory. And you might have realized that I didn't say she was employed there, because she wasn't. She's an amateur. And that term is difficult for us because we associate something with it, like that her research is of a subpar quality, that she's doing research of a lesser kind, like in sports where you have amateurs. This is not the case. I will tell you something about this term in a second, and here it gets really messy. I'm sorry. Because the problem is this term has to do with what we call professionalization of the disciplines of science. And we have literature on the topic of the professionalization in law, in social care, even on the professionalization of taxi drivers, if you're interested in reading up. The problem is that the only thing this whole corpus of literature agrees on is we don't have a definition that we all accept. So we have hundreds of definitions, and this is like a very, not maybe hundreds of definitions, we have lots of definitions, and they don't agree. And I don't want to get into them, because I don't want to discuss all the details that differ. So what I'm going to do instead is give you like an idea of what professionalization is about, so you get a feeling for what is important. And so the important thing is, and I'm going to restrict myself to the sciences, not on taxi driving, we have a job that is turned into a profession. And a profession has a work ethic. And it has an idea of what is proper research and how should proper research be done. And there's a way that you can become a researcher, but it's a very standardized way. And you have to follow this way, and you can follow this way only. And in the sciences, this way is going to university, which have changed in the 19th century. Because you're now taught not only all the details of your discipline, you're also taught arcane experiment and esoteric language. Nobody understands what you are doing anymore outside of universities. And you're taught how to be a researcher. We have laboratories where students now do experiments. We have seminars where in the theoretical sciences, people get taught how to become a researcher. And at the end, you get something very important. And as a German, I can tell you this is the most important thing ever. You get a degree on paper, something that you can hold up. And this certifies that you're a potential researcher. And it can be a bachelor's degree. They're introduced in the 1860s in Oxford and Cambridge. It can be your German doctor title or another PhD. And this serves as part of the demarcation line between professionals and amateurs. And you might recall, amateur was the term I was actually going for. And the problem is that the literature doesn't agree what actually differentiates those two groups. But I will cheat again and give you a very simple definition that you can find in the literature and that will work just fine for the purpose of this talk. A professional is somebody who is paid to do research, and an amateur does research but is not paid for it. It's as simple as that. Okay, and here, before I move on, two important things. First, the professionalization of science leads to the exclusion of amateurs. For quite some time, amateurs and professionals work on equal footing. They both do research. Some of them do bad research, some of them do good research. It's not tied to belonging to either of these groups, but they respect each other and they meet, for example, in societies. The Royal Society was founded to bring together people, both professionals and amateurs, to discuss science. But once the science is completely professionalized, amateurs are completely excluded. And you can see it especially clear in the case of chemistry. That's why I chose this picture. Those are all chemists. In chemistry, which is fully professionalized by the end of the 19th century, we have almost zero amateurs, and they are also pushed out of the scientific societies because the professional alone remains, and he only knows how to do science. And the amateurs are completely excluded. And just to stress that it's really not a question of being an amateur or a professional if you're doing good work. If we take this definition, which is not my idea, you find it in the literature, that amateurs are not paid for their work, while professionals are. Both of these physicists did some of their best work as amateurs. Newton in 1666 moved to the countryside during the plague to revolutionize mathematics and physics. He had no affiliation to any institute whatsoever. Einstein, when he published on special relativity, he was working as a patent clerk, so he was not on a research position either. And there can be no question, their work is outstanding, of course. So good work is not necessarily tied to being a professional, at least in the beginning of professionalization. And I will argue in a second, one of the reasons that we have so many different research approaches in astronomy is due to the fact that astronomy is not fully professionalized during the 19th century. You can clearly see this because there is no standard way to become a professional. Especially in the early part of the 19th century, you can have basically any background. Take a look at these three. That's Urbain Le Verrier. He's director of the Paris Observatory. He will hold 2 different chairs at Paris University, which is now called Sorbonne. So he's a professional. He studied tobacco management. That's Samuel Langley. He's one of the first astrophysicists in the United States. He studied nothing because he only has a high school diploma. And that's Friedrich Wilhelm Bessel. He's the director of Königsberg Observatory, and he has nothing at all. He doesn't even finish school. He's so bad at Latin that he drops out of school. And all of them become professionals, and all of them are eminent and distinguished scientists. By the end of the 19th century, that has somewhat changed. People now, the professionals, astronomers mostly come from related disciplines like mathematics or physics. But there is still no way to become a professional astronomer in a standardized way because you can't study astronomy. We just heard astronomy had been around at universities, and yes, you can hear some lectures, but there is no such a thing as a degree in astronomy. And even if you've heard some lectures in astronomy, that doesn't mean you're necessarily equipped to use the state-of-the-art equipment that you find at observatories. And that brings us back to the question that we haven't asked yet, but we should ask it. Why did Dorothea Klumpke work as an amateur at Paris Observatory? She didn't have a position, she surely wasn't paid, but she was allowed to use the equipment, and her results were published in the yearly reports. And there are 2 reasons for this. This is the first. This is the telescope at the East Tower of the observatory, or it used to be, and it's in a really, really bad shape. The lens is damaged. You can't hardly move it. It takes a lot of force to even move it a little bit. And she asks specifically to use this telescope. And because nobody else cares about it, she can use it. So that's the first smart thing that she does. And the second reason has to do with the so-called École d'Astronomie, the School of Astronomy, founded by Paris Observatory in the 1870s. And it has two purposes. Purpose one, if people want to become astronomers and don't know how to use the instruments, we need to teach them. So they can come there and learn how to use the instruments. Reason number two, anybody can come. They actually advertise it. If you want to go on a holiday and look at the stars, please come, we'll teach you how to use a telescope so you can look at them properly. And this is, of course, unthinkable in a completely professionalized science, that we have one place where these people come together, future professionals and the general public. Moreover, they're actually sort of educating future amateurs. They're showing them how to use the equipment so they can do astronomical research. That's something very interesting, and I don't think something comparable doesn't exist in any other discipline. Sorry, I've got to catch my breath. I'm talking very fast, I'm sorry. The thing is, I made it sound like it's basically a straightforward path. You go to the école, you learn how to use the instruments, and then you go to the observatory and use their instruments. But that is not the case, of course. I'm still flabbergasted to a certain extent why Dorothea Klumpke was allowed to use these instruments. I'm not entirely sure why they did this, because it's more or less a singularity. If we find women who observe during the 19th century, and we have a fair share of women who do that, they're usually amateurs and they do it on their own terms. This is, of course, the most famous example, Caroline Herschel. She's bored. Her brother is doing astronomical observations all night and she's just sitting there. So he gives her a very simple telescope and she does observations on her own and she discovers lots of interesting objects. And that is usually the case. These women have usually learned how to do astronomy from their fathers, from their uncles, from their brothers. And history, unlike mathematics or astronomy, is not an exact science. And that's sometimes very bothering, but it's also what makes it interesting, because whatever you say, you can find a counterexample to that. And I just said, all the women, amateurs in their own private homes. That's, of course, wrong, because here we have one very important counterexample. That's Maria Mitchell. She's from the US. And in the US, we have something we don't have in continental Europe. We have women colleges. Colleges specifically for women. And unthinkably, they hire women as lecturers. Most of them don't do any research at all, they just teach. But in astronomy, it's all different. And Maria Mitchell, who comes from a quite humble background, is taught how to do astronomy by her father and will become, without ever having studied, the first professor of astronomy at Vassar College. She has her own observatory. I'm sorry for the blurry pictures, it's from the 19th century. Some of them look like this. And she does research there, as do her students. But in most of the cases, women who observe do that in a sort of a familiar background in a way, or at least come from such a familiar background. Does that mean we can't find any women at observatories who observe? Is it really only professionals who do observation at observatories? And you have to understand, observatories in a way are the most professionalized part of astronomy at the time. We really have this clear hierarchy. We have male astronomers, we have a clear hierarchy ladder, and only they do the observations. But that doesn't mean we can't find any women. A, observatories need cleaning, so we find women there. B, something has changed. And this is the introduction of astrophotography in the 19th century, and that is a major change in astronomical research. We can now take pictures of celestial objects and look and behold how beautiful they are. It's really amazing to see these things in such detail. You can even see things on pictures that you've never seen before. And you can, because you can't see them with the naked eye. Plus, it's so much easier to take pictures. It's not really easy because it's a lot of technical equipment and so on, but it's easier than observing large portions of the sky in a way. So you can produce tons of data in one single night. And this leads to an interest in the star charts. Star charts are very old. It's basically a chart where all the stars in a certain area of the sky are. But now, with photography, we have a renewed interest in star charts. And somebody needs to evaluate all the data on the tons of photographic plates that are now produced at very many observatories. And it's done by women. They're called computers because they do computation, so that's a real computer. And this is Dorothea Klumpke, and she's the head of the computers at Paris Observatory, where they work on a special star chart called Carte du Ciel. And why do they employ women? They employ them for a number of reasons, and they might be very different if we look at different observatories. For example, in Australia, there's a law that you're not allowed to pay women the same amount as men for the same job. So when you hire women, you save lots of money. That's one of the reasons. That's not the case in France, where you need to pay them the same wages. But women are born to be mothers, and mothers, we all know this, are very patient. And if you're patient with your kid, then you're also patient if you're doing the same repetitive, boring work over and over again. And they actually argue like this. So women are considered ideal candidates. They're also available. We have women with university degrees, like Dorothea Klumpke, who in 1893 will make her PhD with a very technical, very mathematical dissertation on Saturn rings, or in Saturn ring, because they believe it to be one at the time, which is basically one differential equation after the other, and it's just, she calculates constants and so on. So she brings lots of technical knowledge to this job. And women don't go. If they've found a job in science in any way, they just stay. But it's a very specific job, and it's not considered to be research. Research is done when a man looks through a telescope and takes a picture. And it's done when a man takes the data provided by the women and interprets it. What they are doing in between is helping. It's sort of making sandwiches, but in a different way. You know, the hardworking scientist needs some help, so you're doing the boring calculations. As I said, history is a discipline of counterexamples, and here's another one. She's also the most famous one, Williamina Fleming. She starts off as a maid to Pickering. You can see him here. She's a single mom. And suffice it to say, the number of single moms in science is really, really low in other disciplines at the time. She starts off as a maid of Pickering. And he's actually the first to hire female computers. And this is the famous picture that's called Pickering's harem in the literature, which is a horrible term, but that's what it's called, because he starts to employ more and more women, because he's very much relieved that they relieve his astronomers of doing this tedious and repetitive work. And Williamina Fleming is amazing, because she realizes that when she looks at these photographic plates, she can say stuff that's actually research, because she discovers not only, she devises a spectroscopic method to classify stars, she discovers hundreds of before unknown objects. She's the first one to classify something as a white dwarf. But I should add, and this is probably more to do with the fact that she's a computer than the fact that she's a woman. Whenever she finds something, it's not necessarily published under her name or under her name alone. Very often it's published together with Pickering or under Pickering's name completely. And I believe this is very much rooted in the fact that she's a computer. So everything she does belongs to the director of the observatory. And that she's a woman might play a subordinated role in that. And we should give credit to Pickering, because not only lets he publish her alone, but whenever he publishes something under his name that's from her, he gives her credit for it in the text. So that's very progressive of him. And one of the objects I wanted to show you is this. This is the Horsehead Nebula. That's a very recent picture by NASA. It's beautiful. It's discovered by Fleming, and I wanted to show it to you for two reasons. A, the pictures of the 19th century are all black and white and tend to get dull at some point or the other. And this one is amazing. The clarity, it just amazes you. It humbles you to look at this picture. And B, it's a very nice transition to people who are also very much in favor of beauty in astronomy. They stress that the beauty of celestial objects is what astronomy should really be about. But first, let us talk about Jules Janssen. He's a French astronomer. He's not associated with an observatory at the beginning. He starts off as an amateur. He will later be the head of a very specific observatory. And he's very interesting for me, because he tries something for a very short period, which sort of makes him a singularity in the history of astronomy, because not many people do it. And it will only be a very short phase in which it is tried, and it's mainly linked to him. So hot air balloons had been invented by the brothers Montgolfier in the 18th century, and they had been used for science really early on, because people knew what air consisted of, but they had no idea what was going on in higher spheres, in the atmosphere. So they went up, took samples, and analyzed them. And then interest in scientific ballooning waned. That is, until a war started, the Franco-Prussian War of 1870-71. And you may or may not know that Paris was besieged by Prussian troops. Nobody could get in, nobody could get out. until the Parisians decided to use hot air balloons. And they used them for spying on the Germans, they used them to transport supplies, intelligence, and people in and out of Paris. And one of them was Janssen. And why did Janssen leave Paris on a hot air balloon? Because there was a solar eclipse happening, and he just couldn't miss it. So he boarded a balloon, flew out, went to the Mediterranean basin, watched the solar eclipse, and decided, why haven't we astronomers ever used hot air balloons? We should. We have to add, though, that this whole air balloon flight must have been traumatic, probably to Germans shooting from downstairs, because he never went aboard another balloon again in his entire life. But what he did is, he sent other balloonists on his behalf to die. No, and one of them is Dorothea Klumke. You can hardly recognize her, so luckily we have the inscription that it's really her. And she went up in 1899 because people were expecting something spectacular. They were expecting a meteor shower. Meteor showers happen regularly, and the Leonids were expected to be fantastic in 1999 because they had shown fantastic displays in 1866 and 1833. So they were expecting hundreds to thousands of meteors per hour. Dorothea Klumke went up, and to make things short, they just didn't happen, the Leonids. They didn't see any shooting stars. So it was not really a failure, but it was kind of a disappointment. And the year after, she went up again to watch a solar eclipse. And if you read the report she wrote, it's basically a list of synonyms for fog. So she didn't see anything else either. So it didn't really pan out, this idea that you could observe celestial objects on balloons better than you could on Earth. So I'm not going to discuss that. I'm going to discuss the question, why would he send Dorothea Klumke? Why her, of all people? And I believe there's a number of reasons. One of them is she's a woman. Quite a few people had died in ballooning accidents. People had been blown to sea and never returned. People had suffocated in heights. They had frozen to death. There's a very nice report by Wegener. You may know him from Continental Drift, who goes on a long balloon ride and forgets to bring his jacket. So people sometimes did very stupid things, too, on balloons. And lots of people died also from showmanship. There's the very famous case of Sophie Blanchard, she has the doubtful honor of being the first woman to die in an accident in air because she goes up in a balloon and sets it on fire with the fireworks and crashes to her death. So people associate ballooning with danger. And Dorothea Klumke has to write her last will and testament before she's allowed on board. And if you want to establish scientific ballooning as a new method of astronomical research, you need to show it's safe. And what better way to show it's safe than to bring a woman, the feeble sex? That's the one reason, I believe, he took Klumke. And the second reason is, I don't think anybody else wanted to come. Not because of the dying thing. The problem was that most astronomers, I'm going to say professional astronomers, were not interested in ballooning. There was some extravaganza that other people did, popularizers. And once again, the most famous case at hand is Camille Flammarion. He starts off as a very serious astronomer at Paris Observatory, and then he writes a book. The book is called Astronomie populaire, Popular Astronomy, and it's a huge hit. It sells 100,000 copies. That's something we all dream of, that we write a book that sells 100,000 copies. So he gets lots of money, but the people at Paris Observatory are not very thrilled. They kick him out. He doesn't really care because he now can concentrate on what he really wants, and that is popularize astronomy in a way that includes everyone. And he does lots of balloon rides. This is just one of the books that he's written on that topic, and he writes about how beautiful Earth is when you see it from above. Beauty is a very important thing to Camille Flammarion. When you take a look at the first words of Astronomie populaire, he talks about mathematical astronomy. Like the dissertation of Dorothea Klumke, like the star charts, he says, well, we need it in a way. It's part of astronomy. But once you've finished your calculations, please get rid of the calculations. The real important thing is to stare at the sky and marvel at its beauty. Let the calculations fall and let Urania, that's the goddess of astronomy, shine. That's his motto. And he's not only interested in telling people that astronomy is for everyone, he actually does something. Because he has so much money, he just builds an observatory, and unlike the Paris Observatory, really everyone is free to use it. You just have to make an appointment and tell him that you're coming and you want to use his instruments. And you also might remember that in the beginning I said that in chemistry, the amateurs were pushed out of the societies. In astronomy, quite the opposite happens. Camille Flammarion is the founder of the first French astronomical society, Société Astronomique de France. And for those of you who can't read French, I'm going to roughly translate it. Everybody can come. Persons who do practical astronomy or theoretical astronomy, or who are interested in how this science develops, so in the history of astronomy. And it is for l'éclairement d'esprit, it's for the enlightenment of the spirits. So this is a society founded in 1887 for the exact purpose to invite everyone. Everyone is invited to join astronomical research. And something very similar happens here in the UK. This is, Oh, I'm sorry. They already have the Royal Astronomical Society, and the Royal Astronomical Society has not begun to push out amateurs, as they will in the next decades, but they've refused to include women. They tried to vote women into the Royal Astronomical Society, and the Royal Astronomical Society said no. And thus, some enthusiastic amateurs, some professionals, they grouped together and founded a new association, the British Astronomical Society, open to all persons interested in astronomy. You don't even have to do it, you just need to have an interest for it, ladies as well as gentlemen. So we have sort of a movement that tries to bring in everyone into astronomy, everyone who has the slightest interest in astronomy at all. And I need to finish, so I'm not going to talk much about eclipses because we will have a lovely talk in a minute about them. I'm just wanting to say, in 1896 there was an eclipse, and eclipses have been watched in the late 19th century. Like all eclipses were watched by many people from all kinds of different astronomical communities. And in 1896, the British Astronomical Association made an expedition. You could come there. Dorothea Klumpke, she was part of that expedition. As were other people. They bring huge telescopes. So they have very amazing equipment. We can see Edward Maunder, he's the president of the British Astronomical Association. He's a professional. He's from Greenwich, and where he has met his wife. She started off as a computer and now is an amateur, and she publishes lots and lots of research together with her husband. You can see Professor Lockyer, who started off as an amateur, is now a professional. We have Dr. Common, who is an amateur, but he is the president of the Royal Astronomical Society. So lots of different people come. And when I say different people, I mean everyone, basically. If you have the money, you can book a cruise to come. And on this cruise ship, you will meet Dr. Common, whom I've just talked about, and you will also meet Sir Robert Ball. He's the astronomer royal, but he's very interested in popularization. So he will give 3 talks just to educate the people on the boat of what is going to happen during the eclipse. And this is the last amateur I want to mention in passing. This is Isaac Roberts. He's one of the so-called grand amateurs. He comes from very humble beginnings. He learns a trade, works his way up, then has so much money that when he retires, he just builds his own observatory equipped with instruments at the state of the art. And he also does astrophotography. So astrophotography is not something that only observatories do. And this is his amazing picture of Andromeda, which is still called a nebula at the time, because people are still trying to figure out what it actually is. We know it's a galaxy now. And I just want to mention him because he steals Dorothea Klumpke's heart during this expedition. They will marry in 1901, and then she will quit Paris Observatory because he has an observatory. Well, she can go there and work with him. And when he dies, only a couple of years later, she will be an amateur again for the rest of her life. But in conclusion, now finally, I want to say that this eclipse in a way is a snapshot of all the different approaches to astronomical research we have at that time. Not all of them, by far, at least some of them. We can see it's a cornucopia of approaches. We have Common, who is an amateur but can still be president of the Royal Astronomical Society. We have Mademoiselle Klumpke, who in a way represents technical, theoretical astronomy, if you will, but she's here as an amateur. She's also a computer at the time. We can see Sir Robert Ball, who is a professional but still interested in popularization. So we see that there are lots of actors in the 19th century who really strive to bring all different kinds of people into astronomy. There's actually, I'm not going to call it a movement, but There are very many possibilities to participate in research, and thus we find lots of people we would never find in other disciplines. Thank you very much.
Thank you very much indeed for your talk. I wish my so-called German was even 2% as good as your English. You showed a slide with 3 persons who had no background in mathematics. One of them was Bessel.
Yeah.
Is that the Bessel to whom reference is made, if my memory serves me, in advanced calculus books to Bessel's function? And was Bessel a kind of early type of Ramanujan?
Oh, okay. No, the Bessel functions are named in his honor, and no, he didn't go to school, he didn't finish school, he didn't go to university, he still developed them because he needed them for his practical work. And I wouldn't go so far to call him the Ramanujan, because he knew what he was doing. He was just reading up on these things. He learned them himself. Ramanujan is this weird story that the goddess sent him these equations in his sleep, and he suddenly, or for whatever reason, he saw things that no one saw. Bessel worked really, really hard for his mathematics, but he needed that for his observatory.
Okay, thank you very much, Eva, for a fantastic talk.